So this is the Edexcel GCSE paper, Tuesday, 6th of November 2018. Question 1. So just on the index laws. So for the numerator, 3 to the power of 7 multiplied by 3 to the power of minus 2. When you're multiplying, you add the powers. 7 added together with minus 2, so 7 minus 2 is 3 to the power of 5. So our numerator is 3 to the power of 5. We've got to divide this by the denominator. Now when we divide, we subtract the powers. 5 take away 3 is 2. So our final answer is 3 squared. What is 3 squared? Well, 3 times 3 is 9. Question 2, part A. So we've got to work out the value of v here. V squared equals u squared plus 2as. Okay. So u squared. So 12 times 12 is 144. Then we've got to add 2 times minus 3 times 18. Now 2 times minus 3 is minus 6. A positive times a negative is a negative, so it's minus 6. So minus 6 times 18. Well, let's just quickly work out what 18 times 6 is. 6 eighths are 48. 1 6 is 6, and add the 4, that's 108. So 18 times minus 6 is minus 108. So 144 minus 108 gives us 36. Now v squared is 36. So v has to be the square root of 36, which is either 6 or minus 6. Remember, 6 times 6 is 36, but also minus 6 times minus 6 is also 36. So you did have to give both answers there for to get the 2 marks. Now 2 part B, we've got to make s the subject. So rather than it being v squared equals something, we've got to have s equals something. So we need to work our way undoing the right hand side, so we're just left with s on its own. So for now, leave alone the term 2as and undo the plussing of the u squared. So we're going to minus u squared from both sides. So on the left hand side, we're going to have v squared minus u squared. And at this point, we're just left with 2as on the right hand side. Okay, so we've undone the u squared part. So we're nearly there. We've got to make s the subject. We need s on its own. Now the right hand side means 2 times a times s. So how do we undo that timesing by 2a? Well, we divide both sides by 2a. This will just leave us with s on its own. So to make it clear on the left hand side that all of v squared minus u squared is being divided by the 2a, turn it into a fraction. So we have v squared minus u squared all over the 2a equaling s. So just for your final answer, just write that the other way around, put the s on the left. So s equals v squared minus u squared all over 2a. And that's your final answer. Question 3. So the bonus is shared by 10 people. 40% of the bonus is shared equally between the 3 managers. So that must mean that 60% is shared between the 7 salesmen. So if they were, so 60% goes to the 7 salesmen. Okay, because we've got 40% going to the managers. Now, if they were getting 10%, they would be getting 1/10 of the 2,100, which is £210. But they're getting 60%, so they're getting 6 times as much, so 6 times 210. So 210 times 6. 6 noughts are 0, 1 6 is 6, 2 6s are 12. So they are getting 1,260 between the 7 of them. Okay, the 7 of them. So how much does each salesman get? We need to do 1260 and divide that by 7. Remember, dividing you work left to right, so 7s into 1 we can't do. 7s into 12 is 1 carry 5. 7 8s are 56, and we have the noughts. So each of the salesmen is getting £180 under the original plan. Now, one of the salesmen says, what about if they shared it equally? So if they shared it equally, we have £2,100 being shared equally across the 10 of them, which would be £210 each. Now, if that happened, they are obviously getting an extra £30. 210 take away 180 is an extra £30. So we need to work out, is this extra £30 25% more money? So how do we work out a percentage increase? So we take the increase, which is 30, divide it by the original amount, which is 180, and multiply that by 100 to turn it into a percentage. Now 30 over 180 is the same as 3 over 18. Dividing top and bottom by 3, that's a sixth. So what is a sixth of £100? So we're going to do £100 and we're going to divide it by 6. So 6 into 1 doesn't go. 6 into 10 is 1 carried 4. 6 6s are 36. So let's just go a little bit further. So let's just add some decimals. Okay, so 6 6s are 36, so we carry the 6. We carry the 4. Excuse me, we carry the 4. And we get the same again, don't we? We're then just going to have 6s into 40. Again is 6 carry the 4. And so on. So we're going to be getting 16.666%. So actually, if the bonus is shared equally between the 10 of them, they get an extra 16.6% recurring. So the salesman is not right when he says it. So you need to say the salesman is not correct. Salesman not correct. Not correct. As gets an extra 16.6%, not 25%. Okay. Question 4. So you need to be careful here. It takes 120 minutes to fill a swimming pool from 5 taps. Now obviously that makes it a lot quicker. So if you only had 1 tap, it would take you 5 times as long. So for 1 tap, if we only had 1 tap, okay, it would take 5 times as long. So do 120 times 5. 12 5s are 60. So that's 600 minutes. Okay, now we've got 3 taps, so that's obviously going to speed things up. We're going to do it 3 times as quickly. So we need to do 600 divided by 3, which means it would take 200 minutes. So for part B, state one assumption you've made in working out your answers to part A. So you need to say something like the taps are running at the same speed, or they all take an equal amount of time to fill the pool. All taps produce the same amount of water. So I'm going to go for taps are running at the same speed. So 5 part A, we've got to work out an estimate for the number of seconds the plane takes to travel one mile. So we don't actually have to work it out, we've just got to estimate it. So 213 miles per hour. Now to one significant figure, you're allowed to round these numbers. So to one significant figure, we're saying the plane's doing 200 miles every hour. Okay. Now every hour is every 60 minutes. So let's just break that down. We're going 200 miles every 60 minutes. So dividing both by 10, we're going 20 miles in 6 minutes. Okay. Okay, now dividing that by 2, say, we're going 10 miles every 3 minutes. Now what is 3 minutes? There's 60 seconds in a minute, so it's taking 10 miles to get, we're doing in 180 seconds. So that's taking us 180 seconds to do 10 miles. So how many seconds is it going to take us to do 1 mile? Well, we just need to divide the 180 seconds by 10, so it's about 18 seconds. Now this is one way to do this question. You can obviously estimate it slightly differently. I think the mark scheme allowed any answers in the range from 16 to 20, so 18 is bang in the middle. So part B, is your answer to part A an underestimate or an overestimate? Now I've gone and said it's taking 18 seconds to travel 1 mile. Now what I've gone and done though, I've gone and rounded the speed down, okay? I've gone and rounded the speed down, so I'm saying the plane's actually travelling slower than it actually was. So we're travelling faster, so we would actually have covered that distance quicker. So 18 seconds is an overestimate, okay? It's an overestimate. And the reason we're going to give is because we have rounded the speed down. It's an overestimate as we have rounded the speed down. Okay, I've gone and said it was travelling at 200 miles per hour when it was actually travelling faster than that. So it's actually going to cover the ground quicker than that, so less than 18 seconds. 18 seconds is an overestimate. So question 6. To solve a simultaneous equation, we need to eliminate either the x's or the y's. Now let's call the top one equation 1 and the second one equation 2. Now if I was going to line up the x's, so have the same number of x's in both equations, I'd have to take equation 2 and multiply everything by 5. That's absolutely fine. I think I'm going to go down the other route though. I'm going to take equation 1 and multiply all the terms by 3. So I get 15x plus 3y equals 63. And then I'm going to bring equation 2 underneath it. Now, I've lined up the y's, but the signs are different. The signs are different. Okay, we've got a plus 3y here and a minus 3y here. So in order to eliminate the y's, I have to make the decision to add the two equations together on this occasion. Had the signs been the same, I would have subtracted. So, adding the two equations together, I get 16x. The y's eliminate, plus 3y added together with the minus 3y is nothing, that's the whole point. And 63 add 9 is 72. So 16x equals 72. Dividing both sides by 16, I get x equaling 72 over 16. So we can just simplify that down. So it's even, so that's 36 over 8. Okay, they're still even, so 18 over 4, which is 9 over 2, which is 4.5. Now, to work out my second variable, y, I have to take my 4.5 and substitute it back into either of my original equations. Now, just because I prefer it when there's some additions in them rather than subtracting, I'm going to take my equation 1. So 5x plus y equals 21. And I've just worked out that x is 4.5, so 5 lots of 4.5. Let's have a look. So 5 lots of 4.5. Well, 2 lots of 4.5 are 9, so 4 lots are going to be 18. 18 add 4.5 is going to be 22.5. So I know that 5 lots of 4.5 is 22.5. So 22.5 added together to y is 21. So y must be 21 take away 22.5, which is minus 1.5. So our final answer here is y is minus 1.5. while x was 4.5. So, question 7. Let's start off by working out the area of the semicircle, that bit that I've shaded in orange. So the area of the semicircle. Now the area of a circle is pi r squared. So half a circle, a semicircle, is going to be half pi r squared. Now for this little semicircle down here, the diameter is 20, so the radius is going to be 10. So that's going to be half times pi times the radius, 10 squared. 10 tens are 100. A half of 100 is 50, so that's 50 pi. Okay, now let's go and look at the area of the quarter circle. Okay, the area of the quarter circle. Now the quarter circle is the area that I've gone and shaded in green. Okay, so it's this big area here. So it's a quarter of a circle, so that's going to be quarter pi r squared. It's not the right file there. I should be saying quarter of a circle, shouldn't it? So quarter pi r squared. So quarter times pi. Now the radius of the whole quarter circle is the full 20. So that's going to be 20 squared. Now 20 squared is 20 times 20, which is 400. A quarter of 400 is 100. So that's going to be 100 pi. Now what about the area that was originally shaded in the question, the area in green? That's going to comprise my quarter circle, take away my semicircle. When I take my green shaded area and I take away from that the orange shaded area, I'm left with the original shaded area in the question. So the shaded area equals my area of the quarter circle, which is 100 pi, take away my 50 pi for the semicircle, 100 pi take away 50 pi is 50 pi. So my area of my shaded region is 50 pi. So my shaded region is 50 pi, and I have to take that and divide that by the area of the square. Well, the square has got a base and a height of 20. 20 times 20 is 400. So I've got the area of my shaded region being 50 pi divided by the area of my square being 400. Now we can divide top and bottom by 50, giving me pi over 8 as required by the question. Question 8. So write down the exact value of tan 45. So obviously it's quickest if you've learnt these, but if you haven't, it doesn't take long to work it out. So 45-degree angle is the one you have when you have a right-angled triangle. So let's just do a quick right-angled triangle. Okay, so 90 degrees, 45 degrees, and 45 degrees. And let's choose to make the lengths of the two shorter sides 1. And then by Pythagoras, if we needed it, which we don't on this equation, but on this question, but we might do another time. By Pythagoras, the hypotenuse squared is 1 squared plus 1 squared, which is 2. So that's the square root of 2. Now, tan is opposite over adjacent. So tan 45 is our opposite side. Doesn't matter which 45-degree angle we consider ourselves looking from. So if we're going from here, our opposite side is 1, our adjacent side is 1. Whoops, let's get the pen on. So our opposite side is 1, our adjacent side is 1, so 1 over 1 is 1. Now for part B, we're told that cos 60 equals 0.5. Now cos 60 is our adjacent side over our hypotenuse. So looking from here, cos 60 is our adjacent side of 4 over our hypotenuse, which is x, and we're told that cos 60 equals 0.5. So what must x be such that 4 divided by x equals a half? So x must be 8. 4 divided by 8 equals a half. Question 9. So we're asked on the grid below to draw a box plot. So we're told that the shortest delay was 0 minutes. So put a line in at 0. And we're told the longest delay was 42 minutes. So put a little line in at 42. That should be 42. And then we just go and get our other information from the cumulative frequency table. So we've got 48 trains. A quarter of 48 is 12. So if we go along 12 and down, we get 4. Okay, sorry, that's not very accurate. That should be at 4. It's quite hard to do that on the screen. So that's taking a reading of 4. So our start of our rectangle is going to be at 4. So that's quarter of the way up. Halfway up, we're going to take a reading at 24. So that's coming along here. And that's going to give us a median halfway along the rectangle of 10. So we're going to have that's going to be the middle bit of the rectangle. The second line in the rectangle, not in the middle of the rectangle, but the line inside the rectangle. And 3/4 of 48 is 36. So if you come along using a ruler, go down at 36, you can see we get our upper quartile at 20. So, so just draw a rectangle around, the lines around creating a rectangle there, and a line in the middle. And that is your box plot for part A. So I haven't used a ruler here because it would just take me too long for the video, but I suggest you do, please. So just to recap what we did there, the shortest delay was at 0, longest delay was at 42, taken from down here, and then the quarter of the way up, halfway up, 3/4 of the way up are taken from the cumulative frequency. A quarter of 48 is 12, so I took a reading at 12. I went along, went down and got 4. Half of 48 is 24, so I went along at 24, came down and got 10. And 3/4 of 48 is 36, so I went along at 36, hit my curve, came down and took my reading of 20. Now for part B, when they say compare the distributions, you've got to learn that you need to do two things. First of all, compare the medians. So we can see the median on Monday was 10 and the median on Tuesday was 9. So we want to just go and say something like the median delay time on Monday was greater than the median delay time on Tuesday. So that's our first comment, all right? So the median delay on Monday is greater than on Tuesday. Now, the second comment, you need to comment on a measure of spread. So that can either be the range, so biggest takeaway smallest, or it could be on the interquartile range, which is from quarter of the way up to 3/4 of the way up. In other words, the length of the rectangle. So, so you could either say the interquartile range of delay times on Monday was greater than the interquartile range of delay times on the Tuesday, or equally you could have passed comment on the range itself. But I always think the interquartile range is nicer, so we're just, for our second comment for part B, the interquartile range on Monday is greater than on Tuesday. Now for part C, Mary says the longest delay on Tuesday was 33 minutes. Well, that's true. This means that there must be some delays of between 25 and 30 minutes. Is Mary right? Well, not necessarily. We just don't know, do we? We know that the longest delay was 33. We know 25% of the delays were between what's that number, 17 and 33. But who's to say there were any between 25 and 30? They could all have been lower down, or they all could have been at the top end. So is Mary right? No. So you've got to say no. There may not be any delays between 25 and 30 minutes. They may all be between 17 and 25 or 30 and 33. Okay, so no, all the delays in the top 25% could be between 17 and 25 minutes, or between 30 and 33 minutes. In other words, there's no reason to think they have to be evenly distributed throughout that upper quartile. Okay, so 10 part A. So we have an x minus 1 in the numerator and an x minus 1 in the denominator, because remember the denominator here is 5 times x minus 1 in a bracket times another x minus 1 in a bracket. So one of those x minus 1's can cancel out, leaving you with just 1 over 5 lots of x minus 1. Now for part B, you've just got to recognise that this is one of those which is nearly a difference between two squares. We've just got to do a little bit of provisional factorising. So we can start off by taking 2 outside the brackets. So we have 2 25 minus y squared. And then you've got to realise within the bracket there you've got the difference between two squares. The first number, the 25, is a square number, and then we're subtracting another square number. So leaving the 2 outside, the bracket becomes 5 plus y and 5 minus y. Because if you were to multiply out that pair of brackets, you'd have 5 5s are 25, 5 times the minus y is minus 5y, y times 5 is plus 5y, so those two middle terms cancel out, and then plus y times minus y would give you the minus y squared. Question 11. Now I think we've got a question like this. It's actually quite nice just to put in some real amounts and just work with those. So why don't we go and say that, to start with, let's go and say that 100 grams of cereal costs £10. I know that's very expensive, but it just gives us some nice easy figures to work with. So that's the starting point, all right? 100 grams costs £10. Now Jack's going to put 25% more cereal into each box, and he's not going to change the price. So what Jack's doing, he's basically going to be giving an extra 25% in grams. So 125 grams are going to cost it's going to cost £10. So what we're saying there, so we need to go and make sure whatever Sadia does gives exactly the same value for money, so the same amount per gram. Now what Sadia wants to do, she's going to, what's she doing? She wants to reduce the price but does not want to change the amount of cereal in the box. Okay, so Sadia says she's not going to change the amount of cereal, so she's going to have 100 grams still, but how much is that going to cost? Okay, to give the same value for money. Now we can see the quantity that Sadia has is a fifth less. Okay, 125 grams down to 100 grams, it's a fifth less. Okay, it's a fifth less. Okay, we've sort of multiplied it by 0.8. Okay, so let's just say, so you can either think of it that you're multiplying by 0.8, or I can see that 25 grams out of 125 grams is 20%. So how much is Sadia going to have to charge? She's going to have to charge a fifth less than 10, or 10 times 0.8. She's having to charge £8. But the question says, by what percentage does she need to reduce her price? Well, she's reduced her price by £2. Okay, by £2. It's gone from £10 reduced by 2 to £8. So what's the price reduction? It's the change of £2 divided by the original price of £10, turning that into a percentage. She's having to reduce her price by 20%. Question 12. So we're being asked here to work out the size of angle CA to O. So that's the angle we want to work out there. CA to O. Now, there's a number of ways of approaching this. So if you've got the answer a different way, that's absolutely fine. There's obviously plenty of circle theories you can use to get the answer a different way. Now, the way I see is that let's start off by working out that angle there. Now, that angle there is 56 degrees from the alternate segment theorem. So, yes, so that angle there equals that 56 there. Now, I think it's easiest if you just go and pop in that line there, that radius there. So we've then got an equilateral triangle here, not equilateral, an isosceles triangle with that length being the same as that length. Okay, they're both radii of the circle, but equally this is also an isosceles triangle over here. So given that that base angle is 35, this angle over here is also 35. So therefore we can see that our angle OCA, that angle there, OCA, must be 56 take away 35. 56 take away 35, which is 21. And as I said before, that angle OCA is a base angle of, along with x, of triangle OCA. So given that that angle is 21, our angle x must also be 21 degrees. So you must show all your workings, so labelling the diagram is absolutely fine, but you don't have to go and give a reason for each of your angles that you've worked out. So yes, so just looking at the mark scheme, throughout angles may be written on the diagram except as evidence if correct. Reasons need not be given. Question 13. So we can see this is an enlargement. The shape is getting 3 times smaller. The lengths, each of the lengths is 3 times smaller. So it's going to be enlargement scale factor 1/3. Now, where is the center of enlargement? So if we just go and take the same point on each of the triangles and connect those, so that's just joining that point to that point and that point to that point, you can see that these lines are crossing at the point 2, 2. So our answer should be enlargement scale factor 1/3. So we're going from A to B, not B to A. Scale factor 1/3. Each of the lengths are 1/3 as long. And then center of enlargement 2, 2. So we have to make the 3 points to get maximum marks when describing an enlargement. So enlargement, scale factor a third, centre of enlargement 2, 2. So 14 part A. So we need to work this out to the power of 3/4. So we can either cube and take the 4th root, which is hard work, or we can take the 4th root and then cube, which will be easier. So what number to the power of 4 gives us 16? And that's 2, because 2 times 2 times 2 times 2 is 16. And what number to the power of 4 gives us 81? That's 3. 3 times 3 times 3 times 3 is 81. So that takes care of the 4th root, leaving us to then cube top and bottom. 2 cubed is 8, and 3 cubed is 27. Now for part B, let's work each of these out in turn. So 3 to the power of minus 2 equals a 9th. So therefore A equals minus 2. Now for the second one, 3 to the power of B equals 9, which is 3 squared, multiplied by the square root of 3, which is 3 to the power of a half. Now when we multiply, we add the powers. 2 add a half is 2.5. So, and then for the third one, 3 to the power of C equals 1 over root 3. So that's 1 over 3 to the half. And therefore that is 3 to the power of minus a half. So C equals minus a half. Okay, so A is minus 2, B is 2.5, and C is minus a half. Now we've got to work out A plus B plus C, so that's minus 2, add 2.5, minus a half, and that equals 0. Question 15. Now we're told the area ratio between A and B. So A and B, the area ratio we're told is 4 to 25. Now we really want to get the length ratio. We want to be comparing across the board the length ratios. Okay, because they're asking us at the end work out the ratio of the height of shape A to the height of shape C. So we're interested in the length ratio. Now how do you move between the length and the area ratio? One's one-dimensional, one's two-dimensional. So we square. So to go from length to area, you would square the ratio. To go from area to length, you square root. So the square root of 4 is 2. Square root of 25 is 5. So the length ratio between A and B is 2 to 5. Now with regard to B to C, we are given the volume ratio of 27 to 64. Now how do we move between the volume ratio and the length ratio? Well, the first is 3-dimensional, the second is 1-dimensional. So to go from length to volume, you cube. To go from volume to length, you cube root. Cube root of 27 is 3. Cube root of 64 is 4. So we now have comparable length ratios between A, B and C. So let's just compare across the board. A to B to C, and these are all length ratios. So A to B is 2 to 5 and B to C is 3 to 4. Now we want to be able to compare across the board, so really we want that B ratio to be the same share. So why don't we take the first one and multiply by 3 and the second one and multiply by 5? That would give us 15 in the middle for both. So taking the first one and multiplying both by 3, we get 6 to 15. And taking the second one and multiplying by 5, we get 15 to 20. So we've now got a comparable ratio across the board of 6 to 15 to 20. 6 to 15 to 20. Okay, so looking at that, because we want to work out the height ratio, which is just the length ratio between A and C. So just looking at A and C, we've got a ratio of 6 to 20. Now the question is asking us for it in its simplest form, so halving both, we're getting a ratio of 3 to 10, and that's our final answer. Question 16. So we've got to prove this algebraically. So let's just kick off by letting x equal our recurring decimal, but let's just go and write that out in sort of a longer form. So the dots are on the 5 and the 6, so that's 5, 6, 5, 6, 5, 6, and so on. Now, because we've got the double dot, we're going to choose to multiply both sides by 100. So now I'm going to pop that on top because we're going to take away in a minute. So 100x equals, now obviously as we're multiplying the right hand side by 100, the numbers all move 2 to the left, so we're left with 25.6565656. And you will see, because we've chosen to multiply by 100, the recurring components all lines up. So when we now go and choose to take away the bottom one from the top one, so taking away 100x take away x is 99x, and 25.656565 and so on take away 0.25656565 leaves us with 25.4. okay, because from thereafter it all cancels out. 5 take away 5 is 0, 6 take away 6 is 0, and so on. Now I want to go and divide by 99 here, okay, to make x the subject, but it's a bit untidy to go and have a decimal muddled up with a fraction. So I'm actually going to choose to make it really nice and tidy to multiply both sides by 10. So I go and get 990x equals 254. So I've got rid of the decimal. So now when I go and divide both sides by 990, I get x being 254 over 990. They're both even, so I can halve both of these, and I get 127 over 495, which is what I had to prove, which is what I had to show. Question 17. So we're told 2 points on the line. So we've got 2 unknowns and we've got 2 points. So we can just basically substitute each of these points in to work out what A and B are. So first of all, let's consider the point A, 0 minus 5. So we know when x is 0, y is minus 5. So substituting that in, y minus 5 equals x squared, so 0 squared, which is 0, plus a times 0, which is 0, plus b. So we can see straight away that b must be minus 5. Now let's consider the second coordinate that we know lies on the line, 5, 0. So when x is 5, y equals 0. So y equals 0. So 0 equals 5 squared, which is 25, plus a times x, so a times 5, so that's 5a. And plus b, well, we've just worked out that b is minus 5. So we've got 0 equaling 25 plus 5a minus 5. So 0 equals 20 plus 5a, so a must be minus 4. Okay, 20 plus 5 lots of minus 4 equals 0. So in going back to our original curve, we know y equals x squared plus a times x, so that's minus 4x, and then plus b, so that's the minus 5. So that is our curve. Now we need to find the coordinates of the turning point of this curve. Now I think the easiest way to do this is to complete the square. So because the coefficient of x is minus 4, we choose to halve that and kick off with x minus 2 being all squared. Now multiplying out that, we will get x squared minus 4x plus 4, but we don't want that plus 4, so we back out that plus 4 with a minus 4. Now as things stand, that bit there in purple is exactly equal to x squared minus 4x. Okay, we've just substituted in instead. We've still got the minus 5 on the end. So y equals x minus 2 all squared minus 4 minus 5. So y equals x minus 2 all squared minus 9. Now, having it in this alternative format, it's very easy for us to see what the turning point is, the maximum or the minimum on this occasion. Now, at the minimum point, the y variable is at its smallest value. Okay. Now, when we've got anything being squared, the absolute smallest you can get when you square anything is 0. Okay. Anything minus or anything plus squared is giving you a number bigger than 0. So how do we make this whole first term 0? Well, that is when x equals 2. Because 2 take away 2 is 0, and 0 squared is 0. So what is the y value when x is 2? Well, 2 take away 2 is 0, and squared is 0. Take away 9, that's minus 9. So our turning point, our minimum point, is 2 minus 9. Question 18. So we've got to sketch the graph y equals f bracket x minus 2 close bracket. So it's inside the function. The change here is inside the function. So this affects the x values, but opposite to what you expect. So we've got to add 2 to all of the x values. Okay, so all our x coordinates all shift 2 to the right. So there's our top points. There are where it crosses the axis and the minimum point, giving us that graph there. So whenever the change is inside the function, inside the brackets, it affects the x value opposite to what you would naturally expect. So because we had x minus 2, it's going to be 2 to the right. Had it been outside the function, then it would affect the y values as we would expect. Now for part B, what we can see here is that our x values are changing sign. Okay, so again the change is to the x values, not to the y values, so we just need to reverse the sign inside the bracket. So y equals g minus x is our answer. Okay, it's affecting the x values, if you like, opposite to what you'd expect, but multiplying by minus 1 and dividing by minus 1 has the same effect. Question 19, part A. So g f of x is when the f of x function goes into the g function. So get it that way round. You've got to make sure you're the right way round. So it is the f function into the g function. So just following what the g function says, it's 2 lots of whatever you throw into the machine. So that's going to be our x plus 1 all squared, and then we're taking away the 1. So that's the key bit to understand. We are the x plus 1 all squared replaces the x. So now we've just got to process the algebra. So x plus 1 all squared means x plus 1 times x plus 1, which is x squared plus x, which is 2x, plus the 1, and then we've got the minus 1. So that's 2 lots of x squared plus 2x, because the 1 minus 1 cancels. And then we can factorize and take the x outside to give us 2x, x plus 2, as we were required to show. Part B, we've got to work out the inverse function for g of 7. So we need to start off by working out the inverse function for g. Now g of x equals 2x minus 1. So let's just go and introduce y and say y equals 2 lots of x minus 1. Now to find the inverse function, we've got to change the subject. So let's go and divide by 2. And then add 1. So we have gone and changed the subject here, but remember y is something that we've artificially introduced. So our inverse function, we replace that y with an x. So that equals x over 2, add 1. And remember what this machine does. This inverse machine does the opposite of the g function. So if you had put some input into the g function, you would get some output. that same output, if you put into our inverse function, it would take you back to the original input. So here's our inverse function for g. Now we've got to pop 7 into this machine. So our inverse function of 7 is 7 over 2 add 1, which is 3.5 plus 1, which is 4.5. Question 18. So let's start off by multiplying out the numerator. So we've got root 18 plus root 2 multiplied by root 18 plus root 2. So just doing the clause, we've got root 18 times root 18, which is 18. Then root 18 times root 2 is root 36, which is plus 6. And then we've got our third clause. We've got so we've done those two clauses so far, and then we do root 2 times root 18, which is another root 36, which is 6, and then finally root 2 times root 2, which is root 4, which is 2. And we go and add 18 plus 6 plus 6 plus 2, we get 32. So our numerator is 32, so we've got 32 over root 8 minus 2. Now this needs to be rationalized, so at this point we've got to make the decision to multiply top and bottom by that denominator, but with a change of sign, and you'll see why in a minute. So we're going to multiply top and bottom by root 8 plus 2. So on our numerator, 32 lots of root 8. So let's go back to a blue pen. So we've got 32 lots of root 8 plus 32 times 2, which is 64. And on the denominator, we've got our 4 clause again. Root 8 times root 8 is root 64, which is 8. Then our second clause, that root 8 times that plus 2 is plus 2 root 8. Our clause 3 gives us minus 2 root 8. And our fourth clause, minus 2 times plus 2 is minus 4. Now the whole reason we had this change of sign here in red is that's going to make sure that these terms 2 and 3 cancel out. So we're left with 32 root 8 plus 64 over 8 take away 4. So we've got 32 root 8 plus 64 all over 8 minus 4, which is 4. So we can go and divide both our terms in the numerator by 4. 32 divided by 4 is 8, so we've got 8 root 8, and 64 divided by 4 is 16. Now root 8 is root 4 times root 2, which is 2 root 2. So we can replace that root 8 with 2 root 2. So we've got 8 times 2 root 2 plus our 16. Now obviously 8 2's are 16, so we've got 16 root 2 plus 16. So if we go and factorize that, we get 16 lots of root 2 plus 1. So popping that into the order that we were required to write it, we've got 16 lots of 1 plus root 2, and that's our final answer. So A is 16 and B is 1. Okay, now for question 21, which I think is very difficult and the hardest question on the paper. So this might take me a while. So I've started off already by labeling up the diagram. Okay, so we know that going from O to A is vector A, going from O to B is vector B. We're told that OP to PM is 3 to 2, that's the bit in purple, and we're told that M is the midpoint of AB, hence why we've got A to M and M to B both being 1 each. Okay, now we're being asked to work out the ratio of ON to NB. Now what do we know about ON? So let's just think about ON. If we can work out what ON is, then we're most of the way there. Now what we do know about ON is that it is some unknown multiple of OB. Okay, let's go and call that some unknown multiple alpha. So it's some unknown multiple of the vector from O to B, and obviously the vector O to B is little b. Okay, so what do we see about O to N? There is no A component. There is no A component at all. Okay, there's no A coefficient. Whatever the answer is, it's going to be a multiple of O to N is going to be purely a multiple of the vector B. So we really need to focus on another way of representing for O to N. So what we're going to say is we're going to think about O to N via a different route. So we're going to focus on doing O to N as being O to A and then a multiple of the vector A to P. Okay, so that's going to be our approach to this question. That O to N, we're going to go about it by going from O to A, and then we're going to go A to N, but we're going to be saying that that A to N is some unknown multiple of the vector A to P. Okay, so we're going from O to N via A. We're going to go O to A and then A to N, but A to N is some multiple, some number bigger than 1, a multiple of vector A to P. So really a lot of my effort is now, as a big side working, is going to be to work out what the vector from A to P is. So I need to go and work out what the vector from A to P is. And A to P, I can do that by going A to O and then O to P. Fair enough. A to P, I can go A to O and O to P. Now what do I know about O to P? Going from O to P is 3/5 of going from O to M. So OP is 3/5 of O to M. Just by following that 3 there and the 2 there. So O to P is 3 out of 5 of going from O to M. And what do I know about O to M? Going from O to M is going from O to A and A to M. Now what do I know about A to M? A to M is half of A to B. So I'm bringing into play all the information I've been given in this question. I've bringing into play the ratio of 3 to 2 and the 1 to 1. Now converting all of this into little a's and little b's, O to A is clearly just vector A, and A to B is OA plus OB, which is minus A plus B. Okay, so now we go and multiply out all this vector. So we've got 3/5 of A, and then half times minus A is minus a half A plus a half B. So gathering up our terms inside the bracket, A minus a half A is half A, and then we've got a half B, and then multiplying that out, we get O to P being 3/10 A plus 3/10 B. So I've just worked out what O to P is. Okay. Now going back to at the very top, I was saying that A to P is A to O plus O to P. Now A to O is minus A, and we just worked out O to P to be 3/10 of A plus 3/10 of B. So just gathering that all up, I've got A to P being minus 7/10 A minus 7/10 A plus 3/10 B. So back to over here on the left, we were saying that O to N is O to A plus some unknown multiple of A to P, and I've just worked out that A to P is this bit over here on the right in purple. So going back over here, so we're saying it's O to A plus some unknown multiple of minus 7/10 A plus 3/10 B. Right, and then obviously O to A is A. Okay, O to A is A. Now, I need the A coefficient to be 0. We know that O to N is purely a multiple of B. There's no A in it. Okay, so this beta here must be such that all of this A cancels out. This is the key bit to the question. So beta has to be 7/10. And you'll see why in a minute. If beta is 7/10 and we substitute that in, we have O to N being A plus 7/10, and not 7/10, sorry, I mean 10/7. Beta must be 10/7. Okay, so it's 10/7 minus 7/10 A plus 3/10 B. Now, because I've chosen beta to be 10/7, when we multiply this out, we get O to N to be A minus A minus A plus 30/70B, which is 3/7 B. And those A's have cancelled out. So O to N is 3/7 of B. So look back to the question, was saying O to N is 3/7 of the journey all the way from N to B. So O to N must be 3 and N to B must be 4, such that O to N is 3/7 of B. So our final answer, and sorry this has all got a bit squeezed, our ratio of O to N to B has to be 3/4, and that is our final answer. So let's go and let x be the number of green pens in the box. Okay, it's always best to let x be the smallest. We are told that there are 3 more blue pens, so let's let the number of blue pens be x plus 3. So what's the total number of pens in the box? We're obviously adding these two together. X plus 3 is 2. Okay, so let's work out what the probability is of picking a green pen. So that's the probability of the green pen over the total number of pens, and the probability of a blue pen is the probability of the blue pen over the total number of pens. Now this question tells us that the probability that Simon will take 2 pens of the same colour is 27/55. So we know the probability of picking a green and then another green, or the probability of picking a blue and then another blue, is 27/55. So this is giving ourselves an opportunity to create a new division. So what's the probability of picking a green with your first pick? Well, we've just worked that out. That's x over 2x plus 3. Now, what about a green with your second pick? So you haven't put the green back in. So what's the probability of a green with your second pick? Well, both the numerator and denominator
are going to have to go down by 1, because there's one less green and one less in the total. So that's going to be x minus 1 over 2x plus 2. So that's the probability of a green and then another green. Now the probability of a blue with your first pick is x plus 3 over 2x plus 3. And what about a probability of a blue with your second pick? Well, again, numerator and denominator have to go down by 1. And what we know is that that is 27 over 55. Now we're just going to have to number crunch this, okay? We've got the common denominator of 2x plus 3, 2x plus 1. So multiplying out our numerator, we get x squared minus x. And secondly, we get x squared plus 5x plus 6. And this is all over our common denominator of 2x plus 3, 2x plus 2. And we know that this equals 27 over 55. Okay, so let's go and gather up like terms. So we've got 2x squared plus 4x plus 6 on the numerator, 2x plus 3, 2x plus 2. Okay, so what do I notice? Well, everything in the numerator is even, so why don't we take out a 2? So we're left with x squared plus 2x plus 3. And that second term in the denominator is also even. So let's take a 2 out from that second term. That leaves us with 2 lots of x plus 1. And then, of course, our 2x plus 3. And that's equaling 27 over 55. So I can now cancel those two. So if I now go and multiply both sides by 55, and multiply both sides by 2x plus 3, x plus 1, I'm left with 55 lots of x squared plus 2x plus 3, equaling 27 lots of 2x plus 3, x plus 1. Multiplying all of that out, I get 55x squared plus 110x plus 165 equaling 54x squared plus 135x plus 81. Taking this all to the left-hand side, I get x squared minus 25x plus 84 equaling 0. Now that factorizes. What two numbers multiply to be 84 but add to be minus 25? That's minus 21 and minus 4. So that gives us two solutions, x either equaling 21 or x equaling 4. Now we're told that the total number of balls, pens rather, is more than 12, so it can't be the 4. Now x equals 21. We're asked to work out the number of green pens in the box. The number of green pens which equals x is 21. So green pens